Okay, so this is a function family, guys. Notice all of the graphs for number one, they're all similar. What kind of graphs are these? Yep, they're all linear. So guys, go ahead and write linear for these. And for graphs for number two, what are all of those? Yes, those are absolute value graphs. They all have a V shape. So these are all absolute value graphs. They all have a V shape, whether it's facing up or down, they all have a V shape. Okay, so today we're going to be focusing on absolute value graphs. All right, so this is a linear graph. The basic equation is y equals x, where it starts at 0 and it just goes up 1 over 1. Up 1 over 1. So this is this line. Can also go this direction. This is the basic line y equals x. I'm just giving you guys the parent functions. Parent functions are the simplest functions, okay? So this is the basic linear graph, and this is the basic absolute value graph. This is the equation for an absolute value, and the graph looks like this. So let's talk about the absolute value graph. This point down here is called your vertex. Everyone write vertex. Where's my vertex for this one? Yep, the vertex is at 0, 0. What is the axis of symmetry? Yes. So remember, guys, if you don't remember what axis of symmetry is, let me tell you what it is real quick. The axis of symmetry is talking about the line that goes through the vertex, splitting your graph perfectly in half. Okay? That vertical line that I just drew, it crosses the x-axis at 0. So the axis of symmetry is x equals 0. Okay, please write these two things down. Okay, also on this side, let's write the domain. The domain of this V-shaped graph, this absolute value, was going forever to the left, and it's going forever to the right. So what is my domain? All real numbers, you can also write negative infinity to infinity. Those are all of my x values. And let's talk about the range. Uh-oh, I didn't mean to erase the whole graph. Let me draw it back. This is my absolute value graph. Okay, now let's talk about the range. Remember, the range is the bottom of the graph to the top. So where's the bottom at? Here's the bottom. What's that? 0 to what? There's arrows on the top, so it's going up to infinity. So guys, that is the domain and range. Vertex and axis of symmetry. Okay? So now that we talked all about the parent function, let's look at what happens when I transform it. So let me change the slide. Okay, so we're going to talk about transformations, okay? So I'm going to pause here real quick and I'm going to graph this for you. Okay, so guys, this is the parent function. Notice my equation is written over here, the absolute value of x. Notice what will happen if I put a +2 in there. Uh-oh. A +2 in there. What happened? Which direction did it move? It went to the left. How many spaces? Okay, so guys, in your notes where it says x + 2 on the inside, you're going to write it went to the right 2. It went to the left 2. So guys, write left 2 in that box. Okay, guys, now that it moved to the left 2, is my domain and range still the same? Yeah, it still goes from 0 to infinity. It still goes left to right forever. Okay, so the domain and range didn't change. Did my vertex change? Ooh, normally the vertex was right here, wasn't it, at 0, 0? Now it's here at where? -2, 0. Okay, so my vertex changed because I went to the left. What about my axis of symmetry? Where's the center now? Yep, so my axis of symmetry is now at x equals -2. Does that make sense? All right, let's look at another problem. I'm going to erase this off. What if I change the inside instead of a +2? What if I put a -2? Which direction did it move? It went to the right. So guys, in that box, you're going to put right 2. So whenever you have a minus in here, it went to the right 2. What's your new vertex? Yep, my new vertex is 2, 0, because it went to the right. And what's my axis of symmetry? X equals 2. Is that okay, guys? All right, let's talk about some more transformations. All right, so I'm going to erase this off. Okay, so let's say instead of a -2 in here, all right, so that's my original graph. That's the parent function. Now let's say I'm on the outside and I put a +2. What happened? It went up. So guys, when I put a +2, it went up 2. So let me write that. You're going to write that in your little box. Whenever you see this, it went up 2 spaces. Did my vertex change? My vertex is now right here. So my new vertex is 0, 2. What's my axis of symmetry? X equals 0. Okay, so guys, when it doesn't move left or right, your axis of symmetry doesn't change. Yeah. Okay, so what about my range? What's my range now? Here's the bottom. 2 to what? Infinity, it goes up forever. So my range is 2 to infinity. Okay, let's see if I put a -2. What happened? It goes down 2. Okay, so when you have a -2, it now goes down 2. So guys, this is what I want you to write on your notes. Let me go back to the notes page. What you should be writing here is, let me share. Okay, what you guys should have written was, for this one, you should have written left 2. This one is up 2. This one is right 2. And this one is down 2. Okay, what I want you guys to write on the side, the axis of symmetry it changes if it goes left or right. Okay, so the axis of symmetry will change if your graph moves left or right. Normally it's like this, but if I move this way, your axis of symmetry changed. If I move this way to the left, your axis of symmetry just changed. Also, if you go up or down, your range will change. So however you want to word it, guys, this is what I want you guys to notice. Okay, your range will change if you move up or down. Okay, so let's look at the rest of these transformations. I'm going to go back to my graph. Now, this is the parent function. If I put a 2 in the very front, let's look what happens. Y'all see how it got skinnier? Okay, it's like we stretched it tall and skinny. Okay, this is called a vertical stretch. Notice if I do an even bigger number, like 10, you see how it even gets more skinnier? Or if I put 100 there, it got really skinny. Okay, so guys, the bigger the number, the more skinny it will get. Okay, because look, this parent function, this is your slope. Before, it's just go up 1 over 1, up 1 over 1, up 1 over 1. But if I put like a 3 there, it now goes up 3 over 1. Uh-oh. It goes up 3 over 1, up 3 over 1. Oh, I'm doing this wrong. Up 3 over 1 is right here. Up 3 over 1 right here. Okay, so the slope is much bigger. Okay, so what we're going to call this is called a vertical stretch by 2, because there's a 2 in front. So you're going to write vertical stretch by 2. Okay? And now let's look at the graph again. So if I were to graph this, I'm going to change this. What if I made it negative? What happens? It just flips. Okay, so whenever you have a minus, it just flips. It's still a stretch. So let's say I put a 10 here. It's very skinny. And if I put a negative in front, it's still skinny. It's just facing down. Okay, so all a negative does is just flip it. Okay, now let's do a number that's between 0 and 1. Can y'all give me a number between 0 and 1? 0.5? Okay, so I'll do a half. What happened? Yep, it got wider. We call this a vertical compression. It's like you compressed it down, you squashed it down, and it got fat. Think of dough. When you have like pizza and you push it down, it gets wider and flatter, okay? So this is called a vertical compression. So in this box, you're going to put vertical compression by a half, by 1/2. Okay? And these are for numbers between 0 and 1. Remember, if it's negative, that doesn't do anything. That all it does is flip it. If it's negative, it doesn't affect how skinny or wide it is. Okay? All right. And then for number 9, we're going to call this a reflection. So this reflects over the x-axis. Because remember, it normally looks like this. But if you put a negative in front, it jumps down here. Okay, so it just flips across the x-axis. That's why we call it a reflection. Normally, it faces up, but when you put a negative, it flips across the x-axis and it faces down. That's why we call it a reflection across or over the x-axis. Okay, are those okay, guys? All right, so we know what they look like. Let's talk about some definitions here. So I'm going to pause here real quick. So some definitions. Whenever it moves or shifts, slides left, right, up, or down, we call this a translation. So we'll say the graph translation. We say the graph was translated to the right 3, or it was translated up 5. It was translated down 7. That's the word it uses. A dilation is whenever it's stretched or compressed. It gets bigger or smaller. And then a reflection is when it flips it, just like we saw it flip across the x-axis. That is called a reflection, okay? So you might hear those words being used. All right, so let's look at some examples. I'm going to skip this part. That's not really important. We just did that. Okay, so let's look at some examples. Number 10, what do you think happened to this equation? Okay, so remember, whenever you're inside of here, this determines left or right when it's inside. Yes, this one went down 3. When it's on the outside out here, then this is up or down. Okay, so inside of the absolute value symbol determines if it went left or right. Okay, so this went down 3. So if I were to draw this, guys, it went down 3 spaces. It is now right here. So guys, can y'all tell me what is the range? Give me the range. Put it in your box. What's the range? Where's the bottom? We went down 3, so where's the bottom? -3, and it goes up to infinity. Okay, let's do number 11. What happened here? Yes, it went to the left 7. So guys, if I were to graph it, it went this way 7. 1, 2, 3, 4, 5, 6, 7. That's my new vertex, and it looks like that. So guys, what is my axis of symmetry here? Can y'all tell me? X equals what? -7, because it went to the left 7. All right, let's do number 12. What does this negative in the front do? It reflects over the x-axis. And what does this minus 4 on the inside do? It makes it go right 4. Okay, so guys, if it's a right, it'll have a minus sign, and if it's left, it'll have a plus sign. Okay, so guys, what happened was it went to the right 4 spaces, and now it's facing down because it has a negative in the front. So guys, tell me, what is the range for this one? Where's the bottom? It's facing down. Yep, so negative infinity. And where's the top? 0. So this would be the range. Please write down the range as well. Number 13. The 4 in the front, that will be a vertical stretch by 4, and then it goes up 1. So if I were to graph it, it goes up 1. This is my new vertex. And a vertical stretch, that means it's just skinny. So I'm going to draw it skinny. For this one, what's my axis of symmetry? X equals 0. Yep, it's just right down the middle. X equals 0. All right, let's look at number 14. Look at your notes. The number in the front, it's less than 1. So what will this be? Yes. This will be a vertical compress by a third. Okay, so guys, over here, I'm just going to recap. If you have an x plus 2, this went to the left 2. If you have a x minus 2, this went to the right 2, right? This was in your notes. If I have a number in front that's bigger than 1 like this, we call it a vertical stretch. If you have a number in the front that's less than 1, it's called a vertical compress. So that's why number 14, the number in front is less than 1, we call that a vertical compress. Number 15, I'm inside of the absolute value symbol. Look at your notes. What does it do? Left 2, so write down left 2. Now on the back, I have a minus 5, down 5. And I'll pause there. If you graphed it, it went to the left 2 and down 5. This is my new vertex. Number 16, I have a negative in the front. Look back at your notes. For negative in the front, what did we say? A reflection. So everyone write that. Reflect over the x-axis. Now we're going to do the next thing that they did. I have a 2 right here in the front. What did we say right here when we have a number bigger than 1? Vertical stretch. So this is a vertical stretch by 2. And after this one, I'm going to end here, and then we'll continue after lunch. Okay? Looking back at your notes, whenever you have a minus inside of the absolute value symbol, what are we using, left or right? Right. And how many did we go to the right? 1. All right, I'm going to pause here. All right, so number 17. We have 4/3. Is 4/3 bigger than 1 or less than 1? Bigger. So that means this will be, let's look over here at your notes. If my number in front is bigger, is it a vertical stretch or a compress? Stretch. So this is a vertical stretch by 4/3. Do I have anything inside of the absolute values? No, I do not. So that means I didn't move left or right. And then I have a +2, so then that means it goes up 2. So if I were to graph this, I go up 2, and since it's a vertical stretch, it'll look a little more skinny. It'll be tall and thin, vertical stretch, if I were to graph it. Okay, any questions on these? Yes. This is a vertical stretch because 4/3 is bigger than 1. So if it's a number that's bigger than 1, it'll be a vertical stretch. If it's less than 1, like 1/3 or 1/4, 1/2, that would be a vertical compress. Other questions? All right, next one. Let's move on to this. So this says translated 6 units to the right. So I'm going to have my y equals my absolute value symbol. Remember, guys, whenever you're talking about moving left or right, that'll be inside. So if it's left, you'll have a plus sign. If you go to the right, you'll have a minus sign. Okay, it's inside of the absolute value symbol. So over here, I go to the right. So I'll have a plus or a minus. Minus, and I went to the right 6. So that is your equation. If I were to draw it, it went to the right 6 units. So 1, 2, 3, 4, 5, 6. This is my new vertex, and that's my graph. Next, it says it's a reflection in the x-axis. So guys, when there's a reflection, what do I need? A negative sign, so put a negative in the front. Did I go left or right? We're on number 19. Did it go left or right? No. So there's nothing in it. There's going to be nothing in there with the x. And then it went up 2. So on the end, I'm going to put +2. So what this looks like if I were to draw it, it went up 2. And since there's a negative in the front, it's facing down. That's what that would look like. So guys, what would my range be for this one? What would be my range? It's pointing down, so what's that? Negative infinity, and it goes up to what number? 2. So guys, whenever you have a negative in front, the range will always be negative infinity up to something. And that something will be this number here. Okay, whenever you have a negative in the front, it'll be negative infinity to a number. So we have negative infinity to 2. For this first one that we did, there's not a negative here. So what's the range? It'll be some number and then infinity because it'll go up. Okay? All right, let's do the next. Yes. How about you just move your chair over here or pull up one of those chairs and sit here? Anywhere, just move your chair to where you can see. Okay, next we have a vertical stretch by a factor of 5. So that will be in the front. Compresses and stretches the numbers in the front. And then it says it was translated 1 unit to the left. So for left, I'm going to use a plus sign. So this will be x plus 1. So if I were to graph it, it went to the left 1. So there's my vertex. And it's a vertical stretch. So it's going to be tall and skinny. That's what my graph would look like. So for this one, guys, what would my axis of symmetry be for this one? Here's the middle. Yep, it's the x-axis at -1 because it went to the left 1. So it would be x equals -1 would be the axis of symmetry. Oops. Okay, next one. Number 21, translated 3 units to the right and 4 units down. So it went to the right 3 units. So inside, I will have a 3. It went to the right. So am I going to use a plus or a minus? A minus. And then it went 4 units down, so minus 4. So if I were to graph this, it went to the right 3 and it went down 4. 1, 2, 3, 4. So guys, where is my new vertex? Where's my vertex? Yep, the vertex is at 3, negative 4. That's where my vertex is. Okay, let's do number 22. It's a vertically compressed by a factor of 2/3. So that means in the front, I'll have 2/3. Did I go left or right? No, so I just have an X in there. Did I go up or down? No, okay. Then reflect across the x-axis. That'll be a negative in the very front. So guys, did I move left, right, up, or down for number 22? So what's my vertex if I didn't move? It'll be 0, 0, because it's just right here, but now it's just facing down. Oops. It's facing down and it's a little bit wider. But my vertex is still at 0, 0. It didn't change. Your vertex only changes if you move to the left or to the right, or if you go up or down. That's when your vertex changes. Next one, it's a vertical stretch by a factor of 2. So I'm going to put y equals 2, and then it was translated down, so minus 9. Okay, finally, the last one. Vertically compressed by a factor. Whenever you see the word vertically, just know that you're going to be in the very front. You're just going to put that number in the front. And then it shifted to the left, so that'll be x plus 1. And that's it. Okay, so you guys will now continue on to the practice. I'm going to pause the video here. So guys, I'm going to do problem 9 for you, just to get you started. So this is number 9, the practice problem. Guys, just by looking at it, what are the transformations? Left 5, and then up 3. Can you guys write that down, please? So if it went to the left 5, that means it looks like this. 1, 2, 3, 4, 5, and it went up 3. So this is your new vertex right there. That's what your graph would look like. So what's my vertex? Negative 5, 3. So guys, if you want to work quickly through these, instead of having to draw a little picture off to the side to see what happened, you can just do the opposite of this number and then this number. That will give you the vertex. Okay? Now let's do the axis of symmetry. It'll be x equals, well, if I draw a line through the graph that I just drew, this line right here, what x value is that at? Yep, well, it went left 5, so it's at negative 5. So my axis of symmetry is x equals negative 5. Again, it's the opposite of right here. It's always going to be the opposite. My domain is going to be the same for all of these. It's going to be all real numbers, because absolute value graphs, all real numbers. They go forever to the left, forever to the right. All real numbers. My range, well, guys, is it facing up, right? Okay, it's going to go up to infinity. Where's the bottom? 3, because it went up 3. So here's the bottom at 3. So 3 to infinity. A quick way to do this without having to draw a little picture, you can always draw a picture, but a quick way to do this, your range will always be this number. The number, how it moved up or down, that will always be in your range. If there's not a negative in the front, it's going to go to infinity. If there was a negative in the front, that means it would be negative infinity to 3. That's if there was a negative in the front. But there is not a negative in the front, so this is your answer. Right? Because if there was a negative in the front, here's your vertex, it would be facing down. And the top is at 3. So if it was facing down, it would be negative infinity up to 3. But this one doesn't have a negative in front. Okay? This is facing up. So this one would be your range. Okay, so that is an example completed for you. Yes. Yep. Okay, number 1 was requested. Let's do number 1. Oh, this is the parent function. This is the one we did in your notes. Did it go left or right? Do you see anything in here? Did it go left or right? Nope. Did it go up or down? So it just stayed right here at the center. So your vertex is just 0, 0. Your axis of symmetry is at 0. Your domain is always all real numbers. I'll just put our all real numbers. And then your range, where's the very bottom? At 0. And it goes up to, there you go. That was the parent function. Any other questions, guys? Okay, I'll be walking around if y'all need help. For number 2, this went down 3. So that means my vertex will be at 0, negative 3. This number inside of here will tell me the x value. This number out here tells me the y value. The axis of symmetry, this number tells me the axis of symmetry, and I don't have one. So this is just, x equals 0. Your domain is the same for all of these, all real numbers. Now, your range, it went down 3, so my range will be negative 3, and this is facing up, so it'll go off to infinity. You can also write it like this. Y is going to be bigger than or equal to negative 3, greater than or equal to negative 3. Now, you should be able to do this without having to look at the graph. However, if doing the graph helps you, then by all means, draw the graph. So let me show you what it looks like. I went down 3, so that means 1, 2, 3, I'm right here at negative 3. So my vertex is right there at 0, negative 3. The axis of symmetry goes right down the middle. That's at the x value 0. All real numbers. The bottom is at negative 3. The top goes off to infinity. So that's why I have this as my range. So guys, all of these, you shouldn't have to look at the picture, but if it helps you, by all means, draw the picture. Okay? All right.